When you think of the airline world, you probably picture fancy jets cruising high above the clouds, whisking people across continents at close to the speed of sound. But not all airliners are jets, and in some cases speed isn't such a high priority. For shorter routes, especially those under a few hundred nautical miles, turboprops remain one of the most efficient means of transporting people and cargo from A to B. Turboprops typically burn less fuel than jets and use shorter runways and can land in rugged airports where jets just can't go. And yet, despite these advantages, if you look at the turboprop world today, you're going to notice something strange. By and large, the turboprops that are flying passengers around the world today are older designs. Aircraft like the ATR-42 and 72 and the de Havilland-8 have all been around for decades, and more to the point, the engines powering them are even older. Zero clean sheet turboprop engine designs have entered commercial service in more than 30 years, and that can seem a bit strange. So why has there been so little innovation in this part of aviation? Is there even room or a business case for new turboprop aircraft or engines? And what's next for an industry caught between rising fuel costs, sustainability targets, and the changing economics of regional flying? So today we're going to be looking at the past, the present, and the possible future of turboprops. We'll be exploring why this market has been so stagnant, what new projects might finally shake things up, and why developing a new turboprop isn't nearly as simple as it might seem. Stay tuned. For decades, the turboprop engine was king of short-haul aviation. Back in the 1950s and 60s, turboprops bridged the gap between pure piston engines and full jet power and gave us powerhouses like the Lockheed Electra, which was such a successful platform that the military variations are still in service today. Eventually though, jet airliners took over the longer routes, but smaller turboprops took a foothold in the regional market. Airlines used them for hops of a few hundred kilometers linking smaller cities to the larger major hubs. They were rugged, fuel efficient, and could operate from the shorter runways where jets just simply couldn't go. By the 80s, at the height of their popularity, aircraft like the de Havilland-8, the ATR-42 and 72, the Saab 340, and the Fokker 50 were rolling off the assembly lines in large numbers, and the economics just made sense. Jet fuel was getting more expensive, regional routes were growing, and passengers were used to the hum of propellers. But then, things changed. By the mid-1990s, regional jets started entering the market in force. Think Bombardier's CRJ series or the Embraer ERJ family. These were small jets initially seating around 50 passengers, and they changed the game completely. Suddenly, airlines could offer jet service on the shorter routes. No more propeller noise in the cabin, fewer vibrations, and faster cruise speeds that shaved valuable minutes off block times. For the passengers, jets just felt more modern and comfortable, and with fuel prices dropping in the late 90s and early 2000s, the economics for airlines began to swing towards jets. Turboprops started fading away, partly because technologically they sort of plateaued. But why? Well, one of the biggest challenges for turboprops has always been the propeller itself. The blades generate more drag at higher speeds and noise becomes a problem, both inside the cabin and for communities living around the airports. Engineering quieter props and more efficient gearboxes is actually more complex and expensive than people often realise. Then on the engine side itself, there's been surprisingly little innovation. For the past 40 years, the market has relied almost entirely on a handful of proven turboprop engines, mostly the Pratt & Whitney Canada PW100, a family of engines that powers everything from ATRs to Dash 8s. These are robust, reliable engines, but they're basically evolutionary improvements over designs dating back decades. So why are we still using them? Well, in a word, economics. Developing a new engine, regardless of the type, can cost hundreds of millions. And with demand shrinking because of the rise of regional jets, no engine maker has wanted to take the risk. Even on the airframe side, there's been very little development. The ATR is basically the same plane it was decades ago, and the Dash 8 Q400 paused production altogether back in 2022. So today, we're left with an aging fleet of turboprops, Excellent machines, but based on technology designed for a different era. But even with somewhat aging technology, turboprops are still vitally important in carrying passengers into and out of smaller regional airports. The market will continue to need these planes, but the technology has reached the point where it will have to adapt. Emissions regulations will get stricter, and over the long term, fuel is probably going to get more expensive, all of which is pushing the economics back towards turboprops. But we will need new engines to maximise the benefits of turboprops, and getting such engines is an extremely tall order. But why is it so hard to make a new turboprop engine anyway? Well, I'll tell you after this. Now, as some of you may have heard on our podcast, I made a bit of a mistake a while back by connecting to a hotel's Wi-Fi without giving it a second thought. And a few days later, I found out I'd been hacked. Passwords, logins, personal info, all compromised, and honestly, I should have seen it coming. Public Wi-Fi is super convenient, but it's also one of the easiest ways for hackers to access your data. And what really shook me though was how invisible the whole thing was. No warning signs, no red flags, just a silent breach while I was sitting in my hotel room creating content. And that's when I realized I needed more than just strong passwords. I needed protection that actually followed me around the web. So I did the sensible thing and got NordVPN, and honestly, it was a game changer. Their Threat Protection Pro feature blocks malware, trackers, intrusive ads, and even phishing attempts before they can load. And it even works when you're not connected to a VPN server. So if you do any work on the go or just want to avoid learning the hard way like I did, then this is a simple step worth taking. And right now you can get 4 extra months when you sign up for a 2-year plan at nordvpn.com/mentor. There's a 30-day money-back guarantee too, so you've got nothing to lose. Now, let's get back to the episode. So what is keeping us from designing and certifying new, more efficient turboprop engines? Well, mainly it's simply because the market is just too small. Compared to the narrow-body jets, the entire global turboprop airline fleet is tiny. Even when we consider that turboprop engines go into even smaller executive or general aviation aircraft. But some turboprop engines are still being fitted to larger, more modern aircraft like the Airbus A400M. You know, the one that Tom Cruise likes to hang off. Come on. But these are military planes, and the market for airliner-sized turboprops is a fraction of that of A320s or 737s. And even if ATR or Pratt & Whitney launched the perfect new turboprop tomorrow, the potential customer pool is measured in a couple of hundred aircraft per year, not thousands. And just as a point of comparison, at the Paris Air Show this year, ATR proudly announced that they had ramped up production, producing 56 aircraft in 2024 and aiming for at least 60 in 2025. While Airbus is looking to ramp production by 2027 to 75 A320 series planes per month. ATR has a near monopoly on the market right now, and they foresee demand for around 2,100 new turboprop airliners by 2044. And that is the problem. 2,100 aircraft over around 2 decades just isn't enough volume to justify a $1 billion engine or airframe development program. Engine makers and airframe builders both look for scale. Jets have it, turboprops not so much. And then there's the noise. That's a fundamental technical headache that engineers have to deal with because passengers generally hate it and often cite it as a reason to avoid flying in turboprops. Propellers create a high frequency noise that's really hard to insulate against in the cabin, and the faster you spin those blades and the closer you push towards jet-like cruise speeds, the louder it gets. And this is simply because the blades themselves spin near the speed of sound, which means that the tips of the blades can go past the speed of sound at full power on takeoff, and is what makes that terrible racket. Engineers have tried many new tricks over the decades, including new blade shapes and composite materials, but the physics are stubborn. Those big scythe-like blades moving through the air at transonic speeds are always going to make a lot of noise. But I'm going to come back to that. And it's not just about comfort in the plane itself. Noise regulations around airports are a factor too. While turboprops have developed incrementally at best, turbofans have seen huge leaps forward in efficiency thanks to massive bypass ratios, composite fan blades, geared fan systems, and compressor stages that operate right on the edge of what's possible with modern science. The newer geared turbofans, such as the LEAP engines, have bypass ratios of more than double that of the CFM56s that they're replacing, and come with double-digit improvements in fuel economy. All this means that a brand new turboprop would need to be developed from the ground up as an entirely new propulsion system. Propeller, reduction gearbox, control systems, and noise compliance systems, all of which would need to be certified by regulators. And of course, then comes the airframe itself. The short flight time and lower altitudes that turboprop airliners fly at mean that they wouldn't necessarily get the same gains from the incremental advancements that narrow body and wide body jets have slowly stacked up over the decades. For instance, turboprops have simple straight wings, which give them incredible short field capability and make them very forgiving to fly. But that also means that they can't achieve the same gains that jet aircraft have with narrow, sculpted and swept wings. Also, the design of turboprop aircraft often give them a bit of a weight penalty that even something like a composite fuselage couldn't overcome fully. Most of the turboprops are a high wing design, so they have the ground clearance necessary for their massive propellers. And what that means is that they need a separate wing box and landing gear arrangement like the one on the ATR 72 or those really long gear legs that the Q400 has. The point here is that development-wise, turboprops have sat still for so long now that the efficiency gap between the largest turboprops and the smallest jets has all but disappeared. A brand new Embraer E2, for example, might offer seat-to-mile costs comparable to older turboprops while flying faster and delivering a better passenger experience. Not only that, the E2's shorter flight time means that you could potentially squeeze in an extra flight or two per day in some cases, and suddenly any extra costs per mile associated with running a jet suddenly start paying for themselves. So, the airlines look at the extra time savings, the better experiences for passengers, and have largely decided that turboprops really don't make sense on a lot of routes, especially in North America, unless fuel prices shoot through the roof again. Horizon Airlines, for instance, the regional subsidiary of Alaska Airlines, has recently retired the last of its Dash 8 Q400s, preferring to operate the Embraer E175 as its only type. And Porter Airlines in Canada are also replacing their Q400s with the E2s. So for now, turboprops remain in a bit of a weird place. They're still essential for certain markets and for short-haul routes under about 400 nautical miles. They're fuel efficient, can handle short or rough fields, and are cheaper to operate in some scenarios. But the hurdles in designing and producing brand new ones are big enough that the world will probably keep flying aircraft born in the 1980s well into the 2030s. Or will they? Well, actually, things might be changing, because at least a few manufacturers are trying to break this decades-long stalemate. Let's go back to ATR, a company started as a joint venture between Airbus and Leonardo Aerospace. ATR, as we mentioned earlier, basically has a monopoly right now on the regional turboprop market. Their ATR 42 and 72 families are the backbone of turboprop fleets around the world. Now, ATR know that they can't keep selling the same aeroplane forever, but they are seeing demand for more efficient regional aircraft because these areas have tons of cities spaced out just a few hundred kilometers apart. And most of those airports don't have the long runways or big passenger numbers needed to justify a narrow-body jet. So, a few years ago, ATR started talking about what they call the EVO program, essentially an extensive upgrade of the ATR family. They've been a little quiet recently over the details, but the goal is lower fuel burn, lower emissions, and lower noise. Crucially, ATR targeted a double-digit reduction in fuel consumption compared to today's ATR 72-600, again comparable to the ones that modern jetliners have over their older predecessors, and probably enough to convince airlines to upgrade. But here's the catch. ATR can't really build that plane without a brand new engine that boasts huge efficiency gains. But there is some hope on that front. As I've already said, Pratt & Whitney Canada make the PW100 series engines that power most of the world's turboprops today, and they've been working together with ATR for several years on concepts for a next generation turboprop engine. And one intriguing possibility is hybrid electric assistance, where an electric motor helps drive the propeller during high power phases like takeoff and climb. In 2024, Pratt & Whitney announced actually that they're flight testing this hybrid electric technology on a Dash 8 100 testbed, and they believe that they can achieve a 20 to 30% reduction in fuel burn and CO2 emissions on regional routes. A truly huge leap forward if possible. But other than ground testing and feasibility studies, there's been little to no report on this for some time now. So ATR's Evo got stuck. No new engine means no new aircraft, so ATR postponed further development of the program, but we'll come back to that. Then there's Embraer. A few years ago, the Brazilian company made waves when they started talking about developing a brand new turboprop in the 70 to 90 seat category. The plane would use the modern fuselage of the E-Jet family, rear-mounted engines to reduce cabin noise, and performance that could rival small regional jets. But unfortunately by 2024, Embraer said that the program was on ice. The reason? Well, you probably guessed it, no new engines. And as a result, no new plane until at least the 2030s. Embraer's executives have been pretty blunt. They're not going to commit billions to designing a new turboprop unless an engine manufacturer steps up with a new power plant. So for now at least, Embraer is in a waiting mode. And that leaves the future of new turboprops in a kind of limbo. On one side, airlines in places like India, Southeast Asia, and parts of Africa are demanding newer, cleaner turboprops because jets don't make sense for every route. But again, the engine manufacturers are understandably wary of pouring billions into a market that might only deliver a couple of hundred aircraft a year. So, what about China? Well, China has been slowly expanding its domestic turboprop capabilities, largely focused on the AVIC MA700 program. The MA700 is designed for around 70 passengers with a planned range roughly similar to the ATR 72 and was set to be the first ever fly-by-wire turboprop airliner. But as of 2024, when we last heard of it, the program had been delayed repeatedly. The aircraft had flown in testing, but certification timelines are unclear, and the program has faced both technical and political obstacles. Like the Comac planes that we've mentioned earlier on in this channel, the MA700 is still packed full of Western components. The engines, crucially, come from Pratt & Whitney, and the Canadian government has denied export permits for the engines. So while the MA700 might eventually become a player in Chinese domestic market, it's unlikely to challenge ATR or Embraer internationally anytime soon. And as we talked about earlier, certifying planes outside of China is an effort that can take years, assuming they even try. But there is another future development that could be relevant to this, and it's called the prop fan. Now, prop fans or open fan designs promise jet-like speeds but maintain propeller-like efficiency. And interestingly, one of the most common questions we actually get asked here at Mentour now is, what is the difference between a turboprop and an open fan? Well, technically, an open fan is a turboprop of sorts, but it operates at much higher cruise speeds, potentially solving the speed penalty of conventional turboprops. And as a concept at least, the prop fan keeps popping up as a possible saviour for high efficiency regional aircraft. In the 1980s, GE and other engine manufacturers thought that these might even lead to jet-like speeds, but with turboprop efficiency. GE did actually try it out with the GE36, while Pratt & Whitney tried it with the 578-DX, but neither of them got off the ground. Partly it was because of economics around fuel prices at the time, but more importantly, the technology just wasn't ready. Pratt & Whitney's gearbox just wasn't mature enough to work as well as it should, and the GE non-geared solution for the GE36 just wasn't as efficient. And the composite fan blades just weren't ready either. But since then, fan gearboxes have become much more mainstream. Material science has given us composite fan blades and other key technologies, and computing power has really improved our understanding of fluid dynamics. Plus, customer desires for efficiency means that the interest for prop fan designs is once again really high. Hence the introduction of the CFM Rise program that we've covered before and which could enter service around the mid-2030s. But of course, these engines are meant for planes the size of the Boeing 737 or the Airbus A320, not for regional jets or turboprops. So while open fans are exciting, they're not about to drop into a 70-seat ATR replacement anytime soon. But what if the technology to develop the Rise program also has applications for smaller versions that are the right size, thrust and weight to power turboprop-like aircraft? Could that help pay for the development of a new turboprop/prop fan engine to finally replace the old turboprops we have now? Well, we don't really know the answer to that. And obviously this will depend on the actual progress of the CFM Rise and maybe other such engines, which we'll have to cover in another video. But for now, the turboprop world is waiting. At the Paris Air Show this year, Pratt & Whitney confirmed that they're still working on a hybrid electric propulsion flight demonstrator. And separately, they haven't given up on developing the PW127XT, an improved version of the ATR 72's current engine meant for that EVO project. ATR is watching and waiting for that, and even Embraer could still jump in if an engine appears while regional airlines look on. And in an industry laser focused on sustainability, turboprops are still one of the best tools we have. And beyond that, planes like these are a lifeline for communities served by smaller airports where our jets just can't land. But curiously, with hybrid systems and open fan technologies and other parallel developments at play, when new turboprops do appear, they could look remarkably modern. And they may just prove that the oldest idea in aviation, spinning a big propeller, isn't going away anytime soon. So what do you think? Do you fly on turboprops? Do you like it, or would you prefer not to? Let us know in the comments below. And if you like these videos, please remember to like and subscribe, and also let us know if you'd like Petra and myself to discuss this or other topics in upcoming podcasts over on our Captain Speaking channel. My name's Ben Watts, you're watching Mentor now. Have an amazing week, and I'll see you next time.